Welcome back for yet another exciting video about converting between moles and mass and atoms and whatnot. So for this set of problems, we're going to be looking at connecting atoms to grams and grams to atoms. And so we're going to keep using calcium like we have in the other videos. So first off, if we recognize that we're asked to find a number of atoms and we're given grams, just like every other problem, we want to think about what's the relationship between those two units. So atoms, when we're trying to count atoms, immediately it should come to your brain. Okay, I know that something to do with this number, Avogadro's number. So there's this number of atoms in 1 mole. Now the other half of the definition that we need to be using for this is involving the gram unit. And so for every Avogadro's number of calcium atoms, and that's equal to 1 mole, but the mass of that number of calcium atoms is going to be equal to what we call molar mass, and that's taking the relative mass from the periodic table, expressing it in grams, and so that mass in grams is equal to 1 mole of calcium atoms, which is then containing 6.02 times 10 to the 23rd atoms. So this, again, is the mole definition, and for this problem, though, we're going to be using the atoms part and the grams part, so we're actually going to be using this and this. Now, if they're both equal to the same thing, they're both equal to moles. By our rules that we know in math, these two are also equal to each other. If you want to do these problems in 2 steps, you can. If you want to do them in just 1 step, you can also do that. So again, these 2 things are equivalent to each other, and that's what we need in order to solve any sort of problem where we're converting from one unit to another. So once we come up with the relationship, and again, these 2 parts of this relationship will always be identical. 1 mole of something has this number of particles in it. This number over here is going to vary depending on what I'm told the substance is. So because that's grams of calcium, that's why I chose that mass. That's the molar mass for calcium from the periodic table. Okay, so set up the problem. Take the number given in the problem with its units. We're going to write it down, and then we set up a conversion factor to multiply it by to convert to the units that we're looking for. So I want how many atoms? So I want atoms. So I'm going to pick the number from this relationship that has the atoms unit. Put that on the top. And then on the bottom, I'm going to pick the number that has the mass unit to cancel out with this. And that goes on the bottom, so 40.08 grams. So I see the gram here and the gram here. Those are going to cancel and be left with atoms, which is what I want. And so I've got 98.2 times 6.02 times 10 to the 23rd. Make sure you're using your button for scientific notation correctly, and then divided by 40.08. And I get, do not forget to put your exponents down, right? So my calculator has a little 24 in the corner, so I know that I'm keeping 3 significant figures because that's what my original number had. This has 3 significant figures, and then don't forget the times 10 part. There's a 24 over the far right-hand side of my calculator, so that is times 10 to the 24th. The unit, every number has a unit, that is atoms. So 98.2 grams of calcium contains 1.47 times 10 to the 24th atoms. Does this answer make sense? I don't know, these are pretty big numbers. Can we make sense of them? Well, let's see here. This number of atoms has 40.0 grams. So if I had 98.2, so that's more than twice the mass of 1 mole, then I've got more than twice the number of atoms. So yeah, that does actually make sense. Moving on to the next problem. So this is exactly the reverse, exactly the opposite. In this problem, I'm looking for grams. I'm given a number of atoms, and so I can set this up by putting the number given in the problem out in front with its units, and my conversion factor, guess where it's coming from? The mole definition. And so the units that I want grams, so I'm going to put the 40.08 grams, that's the mass, that's equivalent to, and let's see the number of atoms, because again, atom is the unit here, and so I want that matching atom unit on the bottom. I'm going to be dividing by Avogadro's number this time. So 8.61, don't forget to use the correct buttons on your calculator so that doesn't mess this up, times 40.08 divided by 6.02 times 10 to the 23rd. and I get 5.73 grams, because that's the unit that's left over, 5.73 grams of calcium. So for this number of atoms, which is less than Avogadro's number, so that's less than a mole, so my mass is coming out to be less than what the mass of 1 mole of atoms would be. So we can kind of check our logic that way. So when we're counting atoms, we're always going to have a gigantic number as our answer for that. If we are finding a mass, we're going to have a, not as gigantic of a number as that. Some of the numbers are bigger than others depending on how many atoms there are. But certainly we can tell that, the masses are not going to have ridiculous, like times 10 to the 20, 15 even, because that would be way too gigantic. But same relationship, the mole relationship, except this time we're using both legs of the mole relationship, where we're connecting the mass in grams to the number of atoms. And that is it for this video.